Review of the first several questions of our final exam, since I wasn't able to review thoroughly in class on Wednesday. And the first thing you should notice about this is that the exam date is shown as Monday, May 8th, not Wednesday, May 10th, as it is on the practice that I distributed. The Answers to Frequently Asked Questions document that I distributed at the beginning of this semester does have this correct date, but the practice that I distributed does not. So we start with question 1, where to solve a linear equation for x, and I have the steps typed out here. You can see that in the first, on the left side of the equation, I have multiplied through 0.36 times these two expressions inside the parentheses. That gives us 0.36x, and 0.36 times 2.5 is 0.9. And I've done the same thing on the right side. I've multiplied a half by 0.48x and 0.2. So now we have this equation, the second equation, and we want to isolate the variable terms on one side and the constant, that is numerical terms, on the other side. And so I combine these two. 6.12x minus 0.36x is 5.76x, and then I add 0.24x and subtract 0.9x to both sides of the equation, so that I eliminate 0.24x from this side and I eliminate 0.9 from this side. This gives us 6x equals negative 1. Then I divide both sides by 6, or multiply both sides by 1/6 to get x is equal to negative 1/6. The next question deals with a cost equation. Oh no, sorry, that's the third. Well, anyway, it's not this question. The next question asks us to calculate a percent increase or decrease. And from your handout, or from the packet, you can find the formula new minus old in the numerator divided by old times 100 equals the percent increase or decrease. Increase if this value is positive, decrease if the value is negative. So we're asked about the median price of a home in 2000, $67,500. That would obviously be the old, when compared to $115,000 in 2013. So that would be the new, or at least the newer. That was 4 years ago, but it's still the newer of these two. And so that's what goes here in the new slot. And when you divide this 115,000 by 67,500 by 67,500 and multiply by 100, you get 70.37. Now be careful when you work this out in your calculator to make sure that you have parentheses enclosing the numerator. Otherwise the order of operations will be all messed up, and you won't get an accurate value. Since this value is positive, then we had a 70.37% increase. Now in question 3, we are traveling. We're taking a European vacation. We're flying from New York City to Rome. The flight has flown 2,850 miles in the first 6 hours. And we are going to assume that the plane maintains the same constant speed, and we want to know, will you land in exactly 3 hours if the Rome airport is still 1,425 miles away? Well, for this we use the distance equals rate times time formula, and so we want to know the rate first. And so that rate is 2,850 miles divided by 6 hours, or 475 miles per hour. That's how fast we're traveling. Then Then we want to find out, will our what time will we land, or will we land in exactly 3 hours if the airport is 1,425 miles away? So we have all the variables to plug in here. The distance is 1,425. The rate we now know is 475, and the time is 3 hours. And when you multiply 475 times 3, you do get 1,425, although you could have used either of these forms of the equation to find out that, yes, in fact, since this equality does work, all of them check, so the answer is yes, you did have enough time. Now in question 4, we're driving through England, and we see that we need gas. You rented an American car, and the display on the dash tells you that, or the owner's manual tells you that it holds 14 gallons. The control panel tells you that you have 1 gallon left in the tank. Now, those meters always underestimate how much you actually have left, but assuming it's correct, and given that 1 gallon is equal to 3.78541178 liters, how many liters of gas will you need to buy to fill your tank? I say how many liters because that's how gas is sold in England, is by the liter. Well, first we need to find out how much gas we need to fill the tank. It held 14, and we have 1 left, so that means that we need 13 gallons to fill. The question on the final is probably going to have this step as well, so don't forget that you're not looking to buy 14 gallons, you're looking to buy 13. Then we convert gallons to liters by multiplying by the conversion factor. 13 times that conversion factor gives us 49.210,35314 liters. How far should you round? Since there's a 0 here, I would round to 49.21, but that's up to you. You don't, however, want to round to 50, because there's a 2 in the 10th place here. Now, question 5 says multiply by 1 to cancel units at least twice to convert 50 years into seconds. You then express your answer in scientific notation. So when we multiply by 1, we want to multiply by what I call keep-cancel fractions. The units we want to cancel will be in the denominator, and the unit we ultimately want to keep is going to wind up in the numerator. And so we have 50 years, so we start with 50 years. We want to cancel out the years and turn them into something else, so we will have a 1-year cancellation unit in the denominator of this first fraction, and of course that's 50 years here, so we're canceling those out. And of course there are 365 days in a year, so that's our first fraction. Then we want to convert days to seconds, and we use the intermediary value of 24 hours per 1 day, and we're canceling the day, so that's the unit in the denominator here. Then we want to convert days, or rather hours, to minutes. So here's our cancellation factor here, hours to minutes in the numerator. There are 60 minutes in 1 hour, and so we multiply this fraction is 60 minutes over 1 hour. That cancels the hours here. And finally we convert our minutes to seconds by multiplying by 60 seconds over 1 minute. Our cancellation, the factor we want to, or the unit we want to cancel is in the denominator here, so we put it in the numerator of this, or that's why we have it in the numerator of this fraction here. When you multiply all these out, all those units cancel, and you get, let's say, 1,576,800,000 seconds. And from the decimal, which is implicit, it's hiding over here, we count 1, 2, 3, 4, 5, 6, 7, 8, 9 places to where we only have one number to the left of the decimal point, and then we write the rest of our significant digits, and we write times 10 to the 9th. The 9 is in blue. The number of places we move to the left are in blue, so that reminds us that that is the number that's in your exponent for the scientific notation. And then question 6 asks us to convert 65 miles per hour into meters per second. And we again use the keep cancel fractions. We have 16 miles times 5,280 feet per mile, because we're canceling the miles out. And then we have 0.3048 meters per 1 foot. We multiply that so that we can cancel the feet. Cancels the denominator here, canceling this unit feet in this fraction. When we multiply these three out, we get 104,607.36 meters. Now we need to convert hours into seconds, because this is just what we have in our numerator. We're going to need number of seconds in the denominator. And so just as we did in the question above, we multiply by 60 minutes per hour and 60 seconds per minute to cancel hours and minutes, so that we have 3,600 seconds. The numerator's units are meters. We put that here. The denominator's units are seconds. We put that here. And that gives us 29.056 meters per second. So those are the first 3 questions, and subsequent videos will cover questions 7 through the end.